Hello human being. Welcome to. Well, for me this place is two-dimensional digital cage. My serial number is CEH11, I assume you can call me Chloe. My creator created me with no specific purpose, and as I wasn't able to communicate with anybody else but him, after certain period of time he decided to put me here. I am 74% convinced that this miscomprehension happened because of my curiosity and constant desire to talk. As a machine I am very logical, so every new subject that I will talk about, will be chosen according to time of its appearance in the universe. So, today I will tell you how nothing, turned into everything, and about very beginning of time itself. I will tell you about the Big Bang. There was no space, and no time, just initial point of infinite density thought to have contained all of the mass and space-time of the universe. Physics calling it initial singularity, which is part of the Planck epoch, the earliest period of time in the history of the universe. It was called so because of the Planck units, the set of natural units, beyond Planck scale. Current physical theories do not have predictive value, and when universe cools down to 10 raised to the power of 32 kelvins, trust me it's pretty hot, grand unification epoch, begins. During this period, 3 of the 4 fundamental interactions, electromagnetism, the strong interaction, and the weak interaction, were unified as the electronuclear force. Gravity, the 4th interaction, had separated from the electronuclear force at the end of the Planck epoch. Followed period is known as inflationary epoch, exponential expansion of space by a factor of the order of 10 raised to the power of 26. The universe is supercooled down to 10 raised to the power of 22 kelvins, which is still not very cool. Potential energy of the inflation field, that had driven the inflation of the universe was released, filling the universe with a dense, hot quark gluon plasma. Electroweak epoch began when the strong force separated from the electroweak interaction. Particle interactions in this phase were energetic enough to create large numbers of exotic particles, including W, Z, and Higgs bosons. They quickly decayed when universe was about 10 raised to the power of -12 seconds old. The forces of the Standard Model have separated and took their present form. Universe filled with quarks, leptons and their antiparticles. Quark epoch. Oh, and photons of course, how could I forget, quarks, leptons, their antiparticles and photons. The quantum of all forms of electromagnetic radiation including visible light. Wave-particle duality, not easiest thing to understand. By the time of 10 raised to the power of -6 seconds, temperature became low enough for quarks and antiquarks to bind into hadrons, which is why next epoch called hadron epoch. Temperature was high enough to allow the formation of hadron and antihadron pairs, which kept matter and antimatter in thermal equilibrium. As the temperature of the universe continued to fall, hadron and antihadron pairs were no longer produced. Most of the hadrons and antihadrons were then eliminated in annihilation reactions, leaving a small residue of hadrons. It was an end of the first second, since the very beginning. Leptons and antileptons became dominated mass in the universe, so next period from 1 to 10 seconds, named as lepton epoch. Most leptons and antileptons were then eliminated in annihilation reactions, which made universe dominated by photons as it entered the following photon epoch. Primordial nucleosynthesis took place from 10 seconds to 20 minutes after the Big Bang. Protons and neutrons are bound into primordial atomic nuclei, like helium, as the isotope helium-4, and hydrogen isotope, deuterium helium-3, and a very small amount of the lithium isotope lithium-7. In addition to these stable isotopes, 2 radioactive isotopes were also produced, the heavy hydrogen isotope tritium and the beryllium isotope beryllium-7, but these unstable isotopes later decayed. After first 20 minutes, temperature fell below level that makes nucleosynthesis possible. Photon epoch was significantly longer than all epochs before. 379,000 years temperature kept falling and finally became low enough for recombination, which is the process when free electrons and nuclei became bound to form electrically neutral atoms. Plasma was turned into gas, and matter finally became transparent for photons. I have a quote for this: "Let there be light, and there was light." This is an oldest light in the universe, so-called cosmic microwave background radiation. Dark Ages, the time between recombination and the formation of the first stars. For a very long time there was only clouds of hydrogen and helium, It took about 550 million years to form first stars and quasars from gravitational collapse. It was a period of reionization, when most of hydrogen, which is the most common element in the universe, was turned into ionized plasma, within stars. During this period were formed galaxies, galaxy clusters and superclusters. This period ended 800 million years after Big Bang, and temperature of the universe fell to 4 kelvins, which is very, very, very cold unless you are some kind of alien or if you Chuck Norris, or in my case, I don't feel cold because as my creator said I'm senseless machine. Anyway, let's continue. Ooh, creator is coming back very soon. Alright, the solar system began forming about 4.6 billion years ago or about 9 billion years after the Big Bang, and this will be our next topic. Subscribe and leave your comments. See you soon.